In this lesson, we are going to be adding and subtracting two or more radicals. What we need to review quickly is like terms. When we were using like terms for solving equations and inequalities, we would have such things as 2x, and when we were using like terms, we might have 3x. So we could combine those two together and we could get 5x. This is going to be the same thing when we're using radicals. Let's say we have 2 square root of 3, and we're going to add together 4 square root of 3. We need to only combine if they are alike, and they are alike when they have the same exact radical. So we would add the number out front, the coefficient, add those together. 4 plus 2 would be 6, and we keep the radical, which would be the square root of 3. Now there are times when they may look like they are not the same. For example, let's say that I also wanted to add the square root of 12 to that. We will have to simplify first. So we make our factor tree, 4 times 3, 2 times 2. And what we need to remember when we're simplifying is we have our factor pairs. So this would simplify to 2 square roots of 3. Then it would be like the other two, and we could add them together. Remember that unlike terms, when we were adding or when we were solving equations or inequalities, we might have something like 2y plus 3x, and those could not be combined together because they were not the same. So likewise, if we were to have 2 square roots of 3 plus 5 square roots of 2, we could not add these together because the radicals are not the same. They are not like terms. Let's do some practicing. So if I have the square root of 2 plus 3 square roots of 2, we remember that even though there isn't a number written out front, this is going to be 1 square root of 2. So 1 plus 3 would be 4, and we leave the radical, 4 square roots of 2. If we have 4 square roots of 3 plus 2 square roots of 3, we would have 6 square roots of 3. And again, we have 9 square root of 5 minus 1 square root of 5. If the number isn't written there, it's understood to be 1. So we'd have 8 square roots of 5. Let's practice some that aren't necessarily like terms right now. So if we make a factor tree for 12, 4 times 3 and 2 times 2, this is going to be the square root of 2 squared times 2 squared times 3. So that's going to be 2 square roots of 3. So we would have 4 square root of 3 minus 2 square roots of 3, and that's going to equal 2 square roots of 3. When we have one like this, where we have the square root of 45, if we make a factor tree for 45, that's going to be 9 times 5 and 3 times 3. So when we simplify, it's going to be the square root of 3 squared times 5, which equals 3 square roots of 5. But there already is a leading coefficient of 3, and now we have another 3 out front. So those are going to be joined together by multiplication. So we have 9 square roots of 5 plus 2 square roots of 5. So altogether we would have 11 square roots of 5. Here we have 3 square roots of 3, and if we remember the square root of 12, we already simplified that one up here to be 2 square roots of 3. So we have 3 square roots of 3, but there already was a 2 out front. And so since I have a 2 here and a 2 out front, we're going to multiply those together. So that's going to be 4 square roots of 3. And 3 minus 4 would be negative 1 square root of 3. And we don't have to write the 1. So reviewing, make sure that when you are adding or subtracting radicals, that you add or subtract only like terms. and radicals don't change. If it's a square root, it stays a square root. And please remember that you might have to simplify first. Please complete the reflection.